Okay, so the third topic is about how to evaluate your system performance of your information retrieval system. Okay, so in retrieval, we usually use the following metrics. The first one is record. Okay, so record try to return all relevant. All relevant documents you should return to a user. It's called a record. Next is precision. Precision is to measure the. We want your return result should be accurate, should be relevant. Okay, so it's to measure your return information is relevant or not. And the third is ranking. It's called the top rank should be more important. Okay, the three metrics are widely used in information retrieval. Okay, and the others are some systems from the systems aspects. Okay, so like the day link or refresh rate or the response time. Okay, they are system-oriented metrics. Okay, so here this figure I illustrate what is called the recall procedure and the F major. This plot shows confusion matrix. Okay, in confusion matrix, here we have predictive, positive, or negative. So you can think you are in a classification test, and you predict. Okay, these are relevant, some are irrelevant. Okay, you can according to your query, you can divide all your data set documents into relevant or irrelevant. Okay, you can predict. Okay, some are positive, some are negative. Correspond to the relevant and the irrelevant to the queries. And here shows is the actual, the ground truth, the answer or your label. Okay. Also we have a positive and a negative. But for the actual label. And if in this part, if your prediction, you predict, okay, this document is positive, and it's actual is also positive. So we call your prediction for this document is in this area. It's called a true positive. But if you predict it's negative, is irrelevant, but the ground truth is positive, we call your prediction is wrong. But such a wrong situation we call false negative. And also, if your prediction is positive, but the actual is negative, your prediction is wrong. We call such a prediction wrong is false positive. And finally, your prediction is negative, and the actual is also negative. We call it a true negative. Okay, the definition is very clear. Okay, so then based on the confusion matrix, we can define the recall and the precision. The recall is called actually it's a true positive TP, true positive here. The number of true positives and divided by true positive plus false negative. So it's this part, true positive and false negative. There's the sum is these two. So this means the recall try to measure if all the positive answers and actual positive documents should be all returned to a user. Okay, I use this metric to measure, to evaluate what's the recall. So it's calculated like this. How about precision? The precision is used the true positive, the number of true positive here, divided by true positive plus false positive. So here is your denominator. So it means because I predict all these documents are positive, so I will return all these documents to the user. But in fact, only this part are correct. Okay, I can use it to measure this, to measure the quality of the return result. Okay, so it's called a procedure. And recall procedure, you can combine them together to calculate the F measure, like this. Okay, there's a 2 times recall times procedure, and divided by recall plus procedure. And you can get a one value called F measure. But we usually we will check the recall and procedure together. Because the recall and the procedure, they are trade-off in your when you evaluate your system performance. Yeah, generally the trade is usually like this. If your recall is higher, when your recall is higher, your procedure is usually low. Okay, do you know? So what's the reason? If you want to return the all correct answer, return here. If you want to return all the correct answer here, usually you can return all the data set to a user, right? So it means the correct answer is must included in your return result. Okay, so you can get 100% recall because you return all the data set. You return all the data set, so you must in your return result you must include all the correct actual positive. But when you see the procedure will be low because your return result contain many irrelevant documents. So your precision will be very low. Okay. So you should not only check recall or just check the precision. You should take that, consider the two metrics together. Okay, so you can see if your recall is higher, precision is lower. If your precision wants to be higher, your recall is usually lower. Okay, so we call this graph called a PR graph, precision and recall graph. Okay, any problems? And the next is called a ROC curve. ROC curve, here we show they use two metrics called a true positive. Actually, it's recall in your y-axis, and in x-axis is your false positive. False positive is calculated by using your FP divided by FP plus true negative. FP here plus the true negative. So you want to measure the false positive is trying to use this to measure how many false positives in your all negative documents. Okay, so use this as your numerator and then take the sum of your two as the denominator. It's called a false positive. Okay, so the false positive, the figure, it looks like this. Okay, so actually, if you want your true positive to be higher, but at the same time, your false positive rate will also increase. Okay, so it's another figure called ROC curve. Next is called the mean average precision. We usually say just abbreviate as MAP. So MAP is calculated by using this equation. Okay, so you know it's a mean average precision, so it's mainly to calculate your precision. But we will average all your average in this query. In this query, you will return several documents, right? And some documents are correct. We can calculate the average precision. Okay, so I use this example to explain it. So in this case, I give the query, and this query returns, suppose, 10 results. Okay, in these 10 results, we have some 3 of them are correct. Let me copy the example here. I have 3 documents and their rank is your rank. It's a document. So given a query, my information retrieval system is returned 10 results. And 3 of them, these documents are correct. Okay, and their rank are first, at the first place, the 5th place, and the 10th place. Okay, so if you just calculate the precision, what is the precision? The precision is to calculate. In total, you return 10 results, and but only 3 are correct. Right? So your precision is okay. And but if we want to calculate MAP try to consider the rank of this document. Okay, so how to calculate? Okay, so you just check. According to your ranking list, you can find the first correct answer is here. Your first correct answer here, and its rank is 1. So based on this equation, you just check your R is your rank. So your rank is you see it's R. I divided by R. So your R is your rank. Your rank is 1, and I is your how many relevant before this position. Okay, so only 1. Okay, because only 1 correct answer here, and its rank is 1. So we calculate like this. Okay, so we continue because we have 3. So I is from 1 to 3. Okay, so we check the second. The second relevant. Okay, so the second relevant is position is 5. Okay, so it's 5. And how many correct answers? 1, 2, right? A, B. Before the 5th position place, there are 2 relevant. Right? So you see, if we only check the first 5 results, the precision is 2 to the 5th. Okay, and we calculate the third place, the third document. Its place is 10. And okay, so before the 10th place, there are totally 3 documents relevant. Okay, so we can calculate this precision if we only consider the top 10 documents and only 3 are correct. It's the top 10 precision. Okay, so we just calculate the 3 procedures to calculate average. So it's called so it's average. Okay, so in total it's a 1. Okay, so the MAP is calculated. It's this 0.56. Because you consider the rank, the document's rank together. Okay, any problems? Okay, so it's called NAP. It's very widely used in many information retrieval tests. Okay, so next is called NDCG. NDCG is also to count the ranking of the document, but its calculation is more complicated. So recently, we seldom see NDCG now because people prefer to calculate an AP. It's easy to compute and it can also reflect the ranking between these documents. And in NDCG here, if we want to search for K results, top K results here, we hope because we will give each document as an importance. So each document has different documents have different importance. So in NAP we don't count the importance. We just count they are relevant or irrelevant. Okay, but in NDCG we will give the label for all the important, the relevant label of each document. For example, I use the same, all 3 documents, and the document A is relevance is 3. Its most is the highest important, and the document B is the second, and the C is the only 1. Means the document C is less important to the query. And I also give the rank based on my query. Okay, so shows how to calculate this NDCG. So here is the equation. So in these equations you can see the Q is the number of your query. Okay, so and the GK is a normalization term, or it can be calculated according to your ground truth table. Okay, we just focus on this final term. The final term shows the NDCG is calculated like this. So let's give an example to how to calculate it. The calculation looks a little bit complicated. So I have A, B, C, 3 documents, and the relevance, or call it importance. The relevance to the query is 3, 1. The higher the more relevant to the query. And also the rank. Rank is 1, 2, 3. So if you want to calculate this, it's a very labor intensive work because you have to provide a very detailed label information for all the query and their ground truth data. Okay. You have to give. Okay, for each query you have to give the document is importance is 3. The document 2 is 2. The B document is 2, and C document is 1. It's very laboring. You need many manual work to give a label. Okay, so that's why I think NDCG not getting is unpopular as the NAP. NAP is simple. It's easy to compute, and you don't need to spend a lot of time to do the label work. Okay, but if you have such a very good ground truth labels, okay, you can try to calculate this NDCG. Okay, so to calculate, okay, the most important is this equation. Just use an example to show you how to calculate. Okay, so the first is it's a summation. Okay, for the 3 documents. So for the first document, you see, it's 2. For document A, okay, for document A is 2. R is the relevance, so you can see A's relevance is 3. Yeah. Minus 1. And there is denominator is row 1 plus n. N is the position. Okay, the rank position is 1. Okay, put at the first place. Okay, it's for document A. Okay. And for document B, its importance is 2. And its place is at the second place. Okay, it's for document B. This document B is we call it BCG. And for document 3 is just okay, sum the 3 DCG together, and then calculate the normalization term of ZK. You can get the NDCG. Okay, any problems? So the main idea is, if you are more important, you are more relevant, you should put it at the top place. The idea, the main design idea is like this. So if you, so here is a very good, because A is the most relevant, so you put it at the first place. It's good. So this term will be high. If A is put at the last place, you can see its denominator. Although it's very important here, but its denominator will be also large because you put at the last place. So it will get a very large at its denominator here, and the solid is importance. Its DCG will be small. Okay, so the design logic is like this. Okay, any problems? Okay. Next is recall at K. Recall means we calculate how many relevant and you return to the users. Okay, so recall at K is use if you are only one correct answer. Also widely used in like the nearest neighbor search. In nearest neighbor search, you have only one correct answer. The nearest neighbor. Okay, it's correct one. Okay, so only one correct. Okay, so you should the correct answer should be shown in the retrieval set. The retrieval set can be k. Okay, so if k is 1, this means the probability shown in the top one of the correct answer. If k is 10, means I will retrieve 10, return you 10 results. I call the top 10 result, and the correct answer will be shown in top 10 results. And the k is 100 means I will return you 100 results, and the correct answer should be in the set, the top 100 set. Or if it's shown here, the retrieval is success. If not, it's false. Okay, I just compute. So for example, maybe 10,000 queries, and each query I can evaluate. The correct answer is shown in the top k result. Okay, to calculate how many the percentage of queries they achieve, they are correct, they are success or not. Okay, it's called the code in K. Okay, any comments? Okay, that's all. Thank you.